quick video update here of the over unity pulse circuit with the wireless power. We're plugged in, consuming less than 23 watts. That's our input. Here's our output when the circuit pulses. .22 watt pulsed output, and our input does not exceed 22. So I'll zoom back and let you see. Wireless power recharges a cap bank up to 80 volts, goes to this DC step down converter, goes through another cap, timer pulse circuit, steps it up to 80 volts DC, runs the bulb. Hopefully I can get everything in frame. As you see, our output is exceeding our input when we pulse discharge. You're seeing that in watts. Output wattage, input wattage. 22 watts out, 20 watts in. And again, you're seeing it for yourself. 2 watt excess power plus wireless power, unlimited. And keep in mind, when that's occurring, we still have no dampening on the wireless power whatsoever. And that's generating heat. You can, that's hot. So again, what's occurring? Supercap bank powers up. DC boost converter, 0 to 120 volt DC, powers up our transmitter. Transmitter gives off wireless power very efficiently. We collect that wireless power with this special receiver coil and this big insulated aluminum plate that goes through a bridge rectifier. The 80 volt charge is stored in these big capacitors, which are dangerous to touch. That 80 volts goes through this boost converter. As you see, it charges back up. And then that 80 volt charge goes through a timing circuit. We step it down. We go from 80 volts to 12 volts that the relay can handle. And with that 12 volts, we're pulsing it off and on at high amperage. And then that goes through our other boost converter again. We're stepping it back up to 80 volts DC at half an amp to run this bulb in a timed fashion. So that's our input, that's our output. As you see, you have to use this power in timed pulses, and that's where you get the excess power. As you see, we have 2 watts excess on the meter plus unlimited wireless power. So you can't deny that. And I will shut the system off. We lose our wireless power instantly. System will begin to lose its charge. As this big capacitor bank discharges, we are just about dead. And we're dead. And again, I'll turn the system on. Begin to charge up. It's important not to turn this secondary one on until the charge in the caps reaches 80 volts DC. Otherwise, the cycling will never be able to catch up. As you see, an 80 volt DC charge is building up in these big caps. So in theory, having much more of them should help. Okay, we are at 80 volts. We are clear to activate. And I think you get the idea. Wireless power and timed over unity energy pulses from accumulated wireless power. We can clearly see it. There can be no debate or argument about it. We have more output than input. Plus, unimpeded wireless. And if I put a bigger bulb in there, which I don't have, it would spike up to 30 watt output. And keep in mind, when that bulb runs, it doesn't impede our extremely good wireless power effects either. We still have the magic wireless power effects on anything grounded, even on my teacup. Really interesting. It's definitely radiant energy. The wireless doesn't get impeded at all when the light triggers on. As you see, I'm barely in range, and look. Light kicks on, no, the wireless light isn't impeded at all when the light kicks on. So, there's the proof right there for you. Things are getting interesting. And happy holidays. System is now off, and it will cycle down its charge. As you see, we're losing charge, and we're out. And that's that. Added an energy collector here. How sophisticated is that? But no, in all reality, the system is going to get much more improved and higher tech looking than this. Just had an extremely busy month. Holidays, work, family, ridiculously busy. But yeah, thank you everybody to who supports this, and take care. I demonstrated the excess power from the pulse, as well as the wireless power that's unimpeded. So take care, and that's more food for thought.